Okay, Atwood's machine, make sure you've had a read of the question and given it a go. Clearly we've got a heavier weight on this right hand side, so we know that's going to shoot down and the 2 is going to shoot up. But let's get a head around all of the forces acting there using F equals ma. On the left hand side we've got a force of 2g going down, and on the right we've got a bigger force of 3g going down. This whole pulley thing is quite confusing, so it's probably easiest to think of it as a 2 kilogram particle and a 3 kilogram particle on a flat, smooth plane joined by a string. Once we've got it on a flat plane, we sort of need to say that the 2g is acting to the left and the 3g, force of 3g newtons, is acting to the right. Hopefully you just get that there's a resultant force there of 1g acting to the right. That would be 1g, 9.8 newtons acting to the right. That net force is acting on the system as a whole. The 2 and the 3 are connected by a string. They move together. Together they weigh 5 kilos. So we need to think of this F equals ma as a system and go that this net force of 9.8, so the force will equal my mass, which is 5 multiplied by my acceleration. So just use your calculator, divide that through, and I'm pretty sure we get acceleration equals 1.96 meters per second. And now we just need to work out how long it takes to travel the 1.5 meters to the ground. If you're in physics, you're going to go straight to x equals ut plus a half at squared. But bear with me, I've got some maths kids here, and they're not allowed to do that. We're going to start with our acceleration, which is 1.96. We're going to integrate acceleration with velocity and get 1.96 t plus c, and we're going to argue that c is 0 because initial velocity is 0. Then we're going to integrate again to x. Yes, physics, displacement is s, and in maths it's x. We just like to complicate things for you. So that will be 1.96 on 2 t squared plus c. And again, we're going to get rid of that integration constant by saying it starts at 0. You physics kids are just going to say that the initial velocity is 0, and my displacement, or x, whichever you like, is going to be, I want it to travel 1.5 meters. That's going to turn to 0, and I've got this a half a, which is 1.96 times t squared. So that's exactly the same as the maths kids are going to do, and they're going to put the 1.5 right there. So those two equations are actually the same. One specialist maths and one is physics. And oh my gosh, that's just an equation for t. You just n solve that, and you're going to get t. Well, I've got the answer down there. T is 1.237 seconds coming from either of those two equations. And that's it. It's so simple if you think about it on that flat plane, something acting to the left and something acting to the right. Get in, do some practice.